Welcome, and thank you for joining us. Please note that this AI-generated podcast is intended solely for general learning and educational purposes. While we strive to ensure accuracy, the AI may occasionally produce errors or incomplete information. We strongly encourage you to consult qualified professionals and conduct your own due diligence before making any legal, financial, or business decisions based on the content presented here. Also, if you find this content valuable, we kindly request you to like the video, subscribe to the channel, and activate the notification bell to receive updates on future episodes. Let's begin.
Imagine having a shortcut to truly understand the cutting edge of innovation, from artificial intelligence all the way to quantum computing, and how those groundbreaking breakthroughs are actually protected.
Yeah, because that protection piece is absolutely crucial, isn't it?
Exactly, because, let's be honest, that's where the real magic often happens, right?
Yeah.
Knowing how to safeguard those brilliant new ideas. Today, we're not just talking about patents in general, we're taking a really deep dive into the incredibly complex and frankly rapidly evolving world of computer-related inventions, often known as CRIs.
That's right. And our mission today really is to delve into the official guidelines from the Indian Patent Office and also look at some really illuminating recent court decisions. These sources, they work together to clarify what can and what cannot be patented when it comes to technology that might, on the surface, seem like pure software or maybe just abstract ideas. So this deep dive, it's designed to give you, our listener, the most important nuggets of knowledge, hopefully helping you navigate the sometimes murky nuances of patentability for these transformative technologies.
Exactly. The goal is you're going to walk away with a much clearer understanding of the legal landscape, those key definitions we all need, and some truly fascinating examples that highlight that critical distinction between just an abstract concept and a genuinely patentable invention.
Yeah, where that line actually gets drawn.
So let's unpack this. So thinking back over the past few decades, information technology has become this, absolutely vital tool, fundamentally reshaping how we live and work.
Oh, completely. It's hard to even imagine life without it now.
Right. Think about it. Everything from simply inputting and storing data to managing it across these vast networks, intricate hardware, clever software, complex telecommunications. It's all part of this incredible digital transformation that really touches almost every aspect of our lives.
Indeed. And we've seen an almost unbelievable rate of industry transformation because of this. Activities that were once done purely manually are now completely computerized, often much more efficiently. The advent of the internet, the World Wide Web, and then you couple that with this exponential growth in processing power, storage capacity. And it's just opened up capabilities that were, frankly, unheard of before, pushing boundaries constantly.
And here's where it gets really interesting, I think. The current advancements in information and communication technology, ICT, and computer science are rapidly reshaping innovation at an accelerating pace. We're talking about technologies that are no longer just buzzwords in tech journals. They are deeply integrated into our lives, and they're driving completely new ways of thinking about problems and, importantly, solutions.
Absolutely. Just consider artificial intelligence, machine learning, natural language processing, large language models. I mean, these aren't just academic concepts anymore. They are the core technologies enabling really sophisticated automation, providing incredibly customized user experiences, driving predictive analytics across countless sectors. It's everywhere.
Can you give some examples?
Sure. Look at healthcare. We're seeing AI-driven diagnostics helping doctors. In finance, it's transforming risk management models. In education, adaptive learning systems are personalizing how people acquire knowledge. And what's fascinating here is that these technologies aren't just, improving existing systems incrementally. They're enhancing the overall intelligence and responsiveness of the systems themselves. They're making them smarter.
And it's not just the AI, is it? Things like cloud computing, for example, that's been a massive catalyst.
Oh, huge.
It's essentially providing these scalable, cost-effective data storage and processing solutions that are absolutely fundamental to modern IT architectures.
You're spot on. Without the cloud, many of these powerful AI applications simply wouldn't even be feasible at the scale we see them. It's kind of the silent workhorse powering so much innovation behind the scenes.
Definitely the unsung hero sometimes.
And then there's edge computing, which is sort of complementary to cloud computing. Instead of sending absolutely all data to a central cloud, edge computing processes data much closer to the source, right where it's generated.
Which means faster response times, right?
Exactly. It dramatically reduces latency and accelerates real-time analytics. And this is vital for applications like the Internet of Things, IoT, or smart city infrastructure. Think about controlling traffic lights dynamically based on real-time flow, or managing fleets of autonomous vehicles where split-second decisions matter.
Oh, and we absolutely cannot forget quantum computing. This is, well, truly a keystone technology, isn't it? Promising to solve complex problems in mere seconds that classical systems would literally take centuries to process.
The potential is staggering.
Think about its potential impact on critical areas like cryptography, breaking existing codes, creating new ones, climate modeling, even accelerating pharmaceutical development. It's attracting substantial investment, huge amounts, from major tech giants and research institutions, all striving to push it toward commercialization and, harness its incredible power.
And alongside all this computing power, the cybersecurity landscape is also evolving incredibly rapidly. As digital transformation accelerates, cyber threats just grow in complexity. So we're seeing AI-driven threat detection empowering systems to identify and mitigate cyber attacks in real time, often before they cause significant damage.
That's crucial.
And things like blockchain technology, with its distributed ledger mechanisms, provides enhanced data security and immutability, creating records that are incredibly difficult to tamper with. Plus, newer techniques like homomorphic encryption and differential privacy are emerging as critical components. They allow organizations to extract valuable insights from data without compromising individual privacy, which is increasingly important, obviously, for regulatory compliance and maintaining public trust.
And underpinning all of this connectivity, we have the networks themselves. 5G and the upcoming 6G technology are delivering faster, more reliable connections.
Yeah, the bandwidth and latency improvements are key.
They enable these advanced applications in IoT, augmented reality, virtual reality. These high-speed networks facilitate real-time data transmission across countless devices, opening up new possibilities for things like truly immersive gaming, seamless remote work, intelligent smart infrastructure, and even fully autonomous vehicles.
So collectively, what we're really witnessing is that these advancements aren't just isolated breakthroughs. They're converging. They're building this robust, interconnected, intelligent digital ecosystem. And this convergence is driving a massive surge in patent applications, reflecting both the sheer originality of these developments and their incredibly practical applicability in the real world.
Okay, but this rapid pace of innovation, it brings a really crucial need, doesn't it? We need a complementary regulatory system for patent examination that can keep up.
That's the challenge.
Because creators of these computer-related inventions, they consistently seek appropriate patent protection for their innovations. It feels like a constant race between technology development and the legal framework trying to adapt.
Exactly. Patent regimes around the world are grappling with this challenge, figuring out how to efficiently process these cutting-edge applications. And when examining CRIs, it's absolutely essential to consider how these innovations move beyond just traditional software or algorithms to provide a genuine, identifiable technical solution.
That sounds like the core issue.
It really is. This is where the challenge lies. Distinguishing a purely abstract idea from an invention that provides a tangible, technical improvement.
So when we talk about defining CRIs, just to be clear, we're looking at inventions that involve computers, computer networks, or other programmable apparatus and techniques, where one or more features are realized wholly or partially by means of computer hardware or software.
Right. It's that blend, that hybrid nature of instructions interacting with physical components that often makes them so challenging to categorize for patent purposes.
Which brings us neatly to the purpose of the guidelines we're exploring today. For you, the listener, these guidelines from the Indian Patent Office, they aim to foster consistency in CRI patent examination.
Yeah, trying to get everyone on the same page. They provide a common framework for examiners to follow, hopefully reducing subjectivity and ensuring a more predictable outcome for innovators, which is really important.
They also provide much-needed clarity on the exclusions under Section 3K of the Patents Act 1970. The goal being to efficiently examine eligible CRI applications. So, this deep dive, it will explore those specific legal provisions, the examination procedures, and the evolving jurisprudence, how the courts are interpreting things in this field. You're going to get a thorough analysis with key examples and references to recent cases to help you better understand the issues involved.
It's important to note, though, these guidelines are not rulemaking in themselves. The statutory provisions, the actual law, will always prevail if there's any conflict.
Good point.
And these guidelines, they're dynamic. They're subject to court interpretations, statutory amendments, valuable inputs from stakeholders. The legal interpretations we'll mention are powerful, absolutely, but they too are subject to further evolution. The landscape is constantly shifting.
Okay, before we dive deeper, let's unpack some key terms and definitions. Understanding these is absolutely foundational to grasping the nuances of CRI patentability. First up, algorithm. This term, it's often used in software contexts, obviously, but broadly it just means a set of steps or instructions.
Right, a recipe, basically.
Exactly. And as recent court rulings have noted, an algorithm is about the sequential and structured manner of operations to achieve a specific result, focusing on the methodology and originality for the form of expression. It's about the logical flow.
Then we have terms like computer, computer network, computer program, computer system, data, function, information. These are largely defined already in India's Information Technology Act, 2000. They establish the foundational elements of CRIs. For example, a computer program is specifically defined in the Copyright Act, not the Patent Act, as a set of instructions expressed in words, codes, schemes, or in any other form, capable of causing a computer to perform a particular task or achieve a particular result.
Got it. And when we talk about firmware, hardware, and software, these terms are generally defined by their ordinary dictionary meanings, right? Highlighting the physical versus the instructional aspects.
Yeah, hardware is the physical stuff you can touch, software is the instructions, and firmware is kind of that in-between software that's deeply embedded into the hardware, usually unchangeable by the user.
Okay. Now, a really crucial term in patent law, especially for CRIs, is per se.
Yes, per se.
This Latin phrase, as defined by Black's Law Dictionary, means of, in, or by itself, standing alone, without reference to additional facts.
Which means we're considering something in isolation. And that concept is absolutely key to understanding the patent exclusions under Section 3K, particularly for software.
Okay, so let's get to the absolute heart of it. Section 3K of the Patents Act, 1970. This pivotal section, it essentially lists certain subject matter that cannot be patented.
The exclusions.
Exactly. For computer-related inventions, it specifically calls out 4 areas that are generally excluded: a mathematical method, a business method, an algorithm, and crucially, a computer program per se.
And that phrase, per se, is incredibly important here, as you said. When the law was amended back in 2002, the Parliamentary Committee explicitly stated that per se was inserted to clarify that while computer programs as such, just the code itself, are not patentable,
Right.
certain other things ancillary thereto or developed thereon might be patentable if they truly constitute inventions.
So it's not a blanket ban on anything involving software.
Not at all. The intention isn't an absolute rejection for all computer program-related inventions. It's more about focusing on distinguishing a pure abstract program from an invented application of one that has a real-world technical impact.
Okay. And this legal interpretation of Section 3K, it hasn't stood still, has it? It's evolved significantly through court decisions.
Hugely. The case law is dynamic and absolutely crucial for understanding modern CRI patentability. You really have to keep an eye on what the courts are saying.
And the paramount test that seems to have emerged from these rulings, and one you absolutely need to grasp, is this idea of a technical effect or technical contribution. Is that fair?
That's precisely it. When we talk about technical effect, we're essentially asking, does this invention solve a technical problem using technical means to achieve a technical outcome?
Technical, technical, technical.
It sounds repetitive, but it's key. It's about how the invention fundamentally changes or improves the way a machine or system operates, rather than just, say, providing a new way to display information or conduct a business transaction online.
That makes perfect sense. So it's about going beyond just the user interface or a new way to interact on screen.
Exactly. The courts have really leaned into this. For instance, in a case involving Microsoft technology licensing from May 2023, the court emphasized looking at the technical effect produced by the invention. They look at a solution using cookies and two-factor authentication, and it was deemed patentable because its technical aspects, like the complex network-level communication protocols involved, were closer to the heart of computer and network technology, rather than user interface. It solved a technical networking problem, not just a UI one.
Got it. And this is a huge takeaway for you, the listener. A landmark clarification came from a case involving Raytheon Company in September 2023.
Yes, this one was very important.
The Delhi High Court categorically stated, and this is a direct quote from Para 21, that the requirement of novel hardware is a higher standard which lacks any basis in law.
It's massive.
It is. It means that for CRIs, the Patent Office needs to examine if there is a technical contribution or as to what is the technical effect generated by the invention as claimed. So the focus is squarely on the technical impact, not necessarily whether you've invented brand new physical components.
Which is a game changer for software-driven innovations, right? You don't need to build a whole new machine.
Exactly. It's not about building a new machine from scratch. It's about what the software makes a general-purpose machine do that it couldn't before, or do significantly better.
Building on that, in another Microsoft technology licensing case, this one from April 2024, the court elaborated. They said, for inventions involving computer programs to overcome Section 3K limitations, the overall method and system, even when implemented on a general-purpose computer.
Yeah. Must contribute directly to a specific and credible technical effect or enhancement beyond mere general computing processes. It has to be more than just running faster because computers are fast.
Can you give an example of that? They gave a great one. A patent that integrated complex mathematical transformations, like lapped transforms, into a hardware setup for digital media data compression. This significantly enhanced the hardware's functionality, making it patentable. The software essentially transformed a general-purpose computer into a specialized apparatus capable of efficient and effective data compression, which it otherwise was not expected to be capable of.
So it changed the nature of the machine for that task.
Precisely. It wasn't just about running a program. It was about making the machine perform something technically better and more efficiently at a fundamental level.
And the Madras High Court, in yet another Microsoft case, this one from July 3rd, 2024, reaffirmed this principle.
They did. They stated at para 36 that if a CRI results in a technical effect that improves the system's functioning and efficacy, effect on hardware, or provides a technical solution to a technical problem and is therefore not limited in its impact to a particular application or data set, it would surmount the exclusion under Section 3K.
So that's the core principle you should really remember. Look for a demonstrable technical problem and a technical solution, not just an abstract idea or a new way to organize information.
Exactly. And to really try and define what constitutes a technical effect, a case involving ab initio technology from July 30th, 2024, stated at para 38 that technical effect is the bridge or the connect between an input and the processor.
An interesting metaphor.
It is. It clarified that an ingenious input system method that allows the processor to give a more efficient and faster output and computation would result in a technical effect that goes beyond the usual user interface.
So again, not just about pretty graphics or a smoother user experience on the surface?
No, it's about fundamental improvements in how the core system works, optimizing data flow, speeding up processing, making the underlying machine function better.
This emphasis on implementation and technical effect is also crucial for algorithms, isn't it? That was another exclusion.
Absolutely. A case involving BlackBerry Limited from August 30th, 2024 provided some crucial insights here. The court noted at para 48 that if an invention relates purely to a set of instruction or policies which determine the flow without any substantial change in the hardware, it might not be patentable. Which makes sense if it's just a recipe of steps with no real-world technical impact tied to it. Right. But, and this is vital, at para 52, the court clarified, if an algorithm achieves a purpose and results in a technical effect or technical contribution, then the test applicable to computer software can also be applied, and patentability can be adjudged. Okay. In such a case, the inventive feature would have to be the implementation and not the algorithm itself. So it's not the abstract algorithm in isolation that's patentable, but its practical application and the technical result it produces when implemented within a system, or to solve a real-world technical problem.
Okay, now let's turn to the examination procedure itself. While computer-related inventions, CRIs, have these unique challenges because of their nature, they still have to meet the general patentability criteria that apply to all inventions, right?
Oh, absolutely. Those are the gatekeepers. We're talking novelty, inventive step, industrial applicability, and sufficiency of disclosure. These are foundational.
So, novelty first. Of course, it has to be new. An invention can't be patented if it was already publicly known or disclosed before you filed your application or claimed your priority date.
Standard patent law, yes.
And recent court rulings, like the one involving Telefunktiebolaget L. Ericsson from March 2024, have outlined a systematic 7 Stamhas approach for determining novelty.
It's quite methodical. It involves really understanding the claims, what you're actually claiming is new, identifying all the relevant prior art, which is all existing public knowledge.
Books, papers, other patents.
Everything. then comparing the technical details meticulously, assessing whether there are significant differences that indicate genuine novelty, not just trivial changes, and finally, clearly documenting the whole analysis. It's about a thorough, structured comparison.
Okay, after novelty, we get to inventive step, which is often called non-obviousness in other places. This is where it can get particularly tricky for CRIs, I imagine.
It often is. The law, Section 2.1, defines an inventive step as involving a technical advance or having economic significance, or both, and importantly, making the invention not obvious to a person skilled in the art.
That person skilled in the art, the PSI is key.
Absolutely. And the Supreme Court of India, way back in the Biswanath Prasad case from 1982, emphasized judging obviousness strictly and objectively. Hindsight is not allowed.
Right.
They posed a great question to gauge this. Would a competent craftsman or engineer with a common general knowledge of the time facing the problem solved by the patentee, but crucially without knowledge of the patented invention itself, have found the solution obvious?
So would they have naturally arrived at it?
Exactly. Or would it have required that inventive spark? And recent court decisions, like F. Hoffman LaRoche v. Cipla, have reaffirmed this standard, cautioning against just importing foreign tests wholesale.
So the process for determining inventive step, it involves a structured analysis, like the novelty test.
Yes, often a 5-step analysis, also highlighted in that Erickson case. First, identify the hypothetical person skilled in the art. Who are they? What do they know?
Okay.
Second, identify their common general knowledge at the priority date. What was standard practice then? Third, identify the core inventive concept of the claim. What's the actual invention? Fourth, identify the differences between that concept and the existing state of the art. And fifth, the crucial step, determine if those differences would have been obvious to that skilled person without knowing about your specific invention.
Makes sense. It's all about stepping back into the shoes of someone working in the field at that time.
Precisely. After novelty and inventive step, we have industrial applicability. This one's usually more straightforward for CIIs. The invention must simply be capable of being made or used in an industry. It can't just be a pure theory. It needs some practical utility.
Okay, and then there's sufficiency of disclosure, which you mentioned is absolutely crucial for CRIs.
Paramount. The patent application must describe the invention fully and particularly. That's the what and the how, enabling a person skilled in the art, the PNINA, to actually work the invention, to replicate it without needing undue experimentation.
So no guesswork allowed.
No. It needs unambiguous, clear, correct, and accurate descriptions. Think of it as providing a detailed recipe, complete enough for another competent chef to bake exactly the same cake just by reading it.
So for CRIs, what does that mean in practice?
Well, if it's primarily hardware-based, you describe every feature, probably with detailed drawings. If it's a method, you need to describe the necessary sequence of steps, maybe include flowcharts, and crucially, the underlying mechanisms that implement those steps. It needs to be a clear blueprint, not just a high-level concept.
And you mentioned this issue of camouflage earlier.
Yes, particularly with CRIs, sometimes applicants might try to disguise a mere problem statement or a general use case scenario as if it were the solution itself. But the disclosure must be specific and particular to the claimed novel and inventive solution, avoiding that kind of vagueness.
And the claims themselves, they're the legal heart of the patent, defining the boundaries.
Absolutely. They must clearly define the scope of your invention, be succinct, and be fairly based on what you've described in the specification. And for CRIs, claims are construed to ascertain their substance, not just their superficial form, whether it's phrased as a method, a system, or product.
This brings us back to that form and substance distinction again. Section 3K explicitly excludes computer program per se and algorithms.
Right. So if, in substance, a claim, even if it's cleverly worded as a method or a system, actually just represents one of these excluded categories at its core, it's not patentable. The law aims to prevent applicants from camouflaging the true, unpatentable nature of a claim merely by how they write it.
But it's not impossible to claim methods or systems.
And not at all. If the specification provides sufficient support and clearly shows a true technical contribution, both method and system claims can be allowed, even as independent claims. There's no inherent bar just because it's software-related. It always comes back to substance over form.
Okay. And one last point on claims. Means plus function claims.
Ah, yes. These claims often use phrases like means for performing some function without explicitly specifying the hardware or software structure that does it.
Like means for storing data.
Exactly. In such cases, the guidelines in practice require that these means must be clearly defined with corresponding structural features, and often reference numerals pointing back to those structures in the specification. It needs to be clear how that function is actually performed, not just stating that there's a means for it.
So pulling this all together, this is all part of the crucial determination. When does a CRI fall under those Section 3K exclusions?
Precisely. The examiner must judge the substance of the claims taken as a whole. If the substance falls into an excluded category, mathematical method, business method, algorithm, computer program per se, it's not patentable. If it doesn't and meets the other criteria like novelty and inventive step, it should be allowed.
Okay, let's delve into each of the 4 exclusions from Section 3K. Now, maybe with some concrete examples to make it clear. First, mathematical method.
Right. What's excluded here? This refers to purely abstract mathematical processing, things like operations of equations, statistical models used in isolation, or mathematical computations only to define an output value. Think of a patent claim that is essentially just a formula or calculation without any practical technical application tied to it.
But, and this is crucial, right? The mere presence of a mathematical formula doesn't automatically kill the patent.
Absolutely not. If that math has a practical application, if it's part of a larger technical process achieving a broader technical objective, think of coding data for transmission, reducing noise in communications systems using filters defined by math, or decrypting electronic communications, then it can be patentable. The math has to be an integral step towards solving a technical problem in the real world or within a system.
So, how do examiners assess this?
They first construe the substance of the claim. What's its primary objective? Then they determine if the solution's essence is just abstract mathematical processing or if it's genuinely part of a broader technical process. If it's just the abstract math, it's excluded under 3K.
Okay, let's try an example that is not patentable as a mathematical method. The guidelines mention a system for calculating a data compatibility index. The claim involves a processor applying a predefined mathematical formula to data sets just to calculate an index number.
Yeah, the core here is simply the mathematical calculation itself. The computer system is merely a tool to perform the calculation faster. There's no broader technical process or real-world action initiated beyond outputting that index number.
So that's similar to other examples in the annexure, like calculating compound interest, statistical analysis in the abstract, generating random numbers, or solving quadratic equations, all pure math.
Exactly. Purely mathematical computations without a specific technical application or embedding in a larger technical process that achieves something tangible.
Okay, now an example that is patentable, not just a mathematical method. The guidelines give method for controlling a robotic arm.
Right. Here, the claim involves receiving a target position, calculating the necessary joint angles using inverse kinematics equations, which is math, but then, crucially, generating control signals for the robotic arm actuators based on those calculations.
So the math leads to a physical action?
Precisely. The mathematical calculations are intermediate steps used to achieve a physical action, controlling the robotic arm's movement in the real world. This clearly contributes to a broader technical objective beyond just computation. It makes the arm move correctly. This is patentable.
And that aligns with other examples like adaptive noise cancellation in audio devices, using FFTs and filtering math for improved audio output, controlling an autonomous drone, using pathfinding algorithms like Dijkstra's for physical navigation, or image enhancement in medical imaging, using wavelet math for clearer MRI images.
Yes, or even real-time vehicle stability control, where slip ratio calculations adjust braking a physical intervention. In all these cases, the math serves a concrete technical purpose within a larger system or process.
Okay, moving on to the second exclusion. A business method. Now, this seems like it could be a gray area.
It definitely can be. This involves the whole range of commercial or industrial activities related to transacting goods or services. But it's important to understand, just using words like enterprise, business, commerce, or transactions in the claims doesn't automatically make it an excluded business method. The decision always comes down to evaluating the substance of the claimed invention.
So what is typically excluded?
Purely commercial, administrative, or financial strategies. Methods of buying or selling goods online, if the invention is just the selling strategy itself. Schemes for revenue generation, customer management, inventory control. Even if they're implemented using technology, if the core inventive idea resides in the commercial rules, the business logic, or an organizational approach, it's generally not patentable under 3K. The technology is just seen as an incidental tool for carrying out a known business practice.
Right. So conversely, what's not excluded? When does a business-related invention become patentable?
It's when the core of the invention has a technical characteristic relating to the underlying system or process, when it addresses how something is done from a technical perspective, solving a technical problem.
Like,
Think of a novel cryptographic technique developed specifically to secure online banking data transmission, or a new method for technically optimizing server transaction processing to handle higher loads during peak e-commerce times. In these cases, the business context banking, e-commerce, serves only as a constraint or field of use to define the scope, not the core inventive idea itself. The invention is technical.
so the assessment process is similar.
Yes. First, construe the substance of the invention to find its primary objective. Then determine, is the core an administrative or commercial strategy, or is it genuinely a technical improvement to an underlying system or process? If it's the former, it's likely excluded.
Let's consider an example of a non-patentable business method from the guidelines. A system for dynamic pricing of online advertisements. The claim involves a system applying predefined business rules to real-time bid and performance data to calculate dynamic prices for ad slots.
The analysis here shows the primary objective is a strategic commercial approach for revenue optimization in advertising. The technology merely implements business rules that a human could theoretically apply. The core is the business logic of dynamic pricing, not a technical innovation in how the system operates.
And this is similar to other exclude examples like calculating tiered bank service fees based on rules managing loyalty rewards programs or dynamic pricing strategies for ride-sharing services. All primarily commercial strategies enabled by tech, but the invention is in the business rule, not the tech itself.
Exactly. But now consider a method for enhancing cashless payment transactions at a point of sale, POS, which could be patentable. The claim involves technically configuring a POS system with an NFC reader, securely processing payment data using specific protocols, transmitting it for authorization, and completing the transaction.
So the focus shifts.
Yes, here the focus is on improving the operational infrastructure of the POS system through secure, contactless payment processing. It addresses technical challenges like secure data communication protocols, hardware compatibility, and faster transaction finality, thereby refining the system's functionality and security.
So the business context payments is just the field.
Right. The business context serves as a constraint, but the core invention is technical. This is like other patentable examples. A system for secure data transmission in online banking using novel quantum-resistant crypto, or a POS terminal with adaptive signal processing for more reliable card reading, or optimized server load balancing for e-commerce platforms using predictive analytics to reroute traffic. These are technical solutions to technical problems, even though they operate within a business context.
Got it. Now for the third exclusion, algorithm. You mentioned this ties into the technical effect idea.
It does. Algorithms in all forms, whether described as rules, procedures, steps, finite instructions, logical, arithmetical, or computational methods, are excluded from patentability if they remain abstract concepts.
What makes an algorithm claim abstract?
A claim is considered abstract if it's merely a sequence of procedural steps presented without sufficient technical implementation details, effectively detached from any practical application or specific technical context. So, for example, a basic sorting algorithm, if the patent application only lists the steps like partition the array, recursively sort subarrays, without specifying how these steps are technically applied in a specific concrete system to solve a real problem, like, say, optimizing database query performance in a specific cloud architecture, or managing real-time data streams from sensors in a 5G network, it might be seen as just an abstract idea, a mathematical recipe.
So it needs grounding in reality.
Exactly. The invention must provide specific enabling details showing how it solves a real-life technical problem, transforming the abstract algorithm into a practical, tangible innovation.
So this means including not just the algorithm's logical flow, but also its technical realization or application within a specific technical framework to provide a verifiable technical solution.
Precisely. The assessment steps involve construing the substance to identify the steps, then determining enablement and abstractness. Does it specify technical components? Does it solve a real-world technical problem? Does it provide a concrete technical solution? If not, it likely falls under the algorithm exclusion.
Okay, an example of a non-patentable algorithm from the guidelines, a method for cryptographic key generation. The claim describes abstract steps like receiving a seed value, applying mathematical permutations, and outputting pseudo-random numbers.
The analysis here is that these steps are highly abstract. It lacks specific technical implementation details. How are the permutations chosen or executed? What hardware performs this? Crucially, how are these generated numbers actually used to solve a specific technical problem, like enabling secure communication between two defined points? It just generates numbers in a vacuum without connecting that generation to a concrete technical application or improvement.
So this is like other abstract examples, like a generic sorting algorithm or a text tokenization algorithm, which are just sequences of steps without specified technical implementation or real-world technical applications.
Right. But contrast that with a method for secure data communication, which could be patentable. This claim involves generating pseudo-random numbers to be used as session keys, then using them to encrypt data with a specific engine like AES-GCM, encapsulating the encrypted data in a network packet using a particular process, and transmitting it via a network interface controller.
Much more concrete.
Exactly. This involves specific technical components, a cryptographic processor, the AES-GCM encryption engine, the NIC's packetization engine, integrated to provide a technical solution to the technical problem of ensuring secure data transmission. It's a tangible technical workflow applying the algorithm, not just the abstract idea of the algorithm itself.
And this principle also covers things like secure biometric authentication using a specific algorithm on a mobile device's secure enclave, or real-time video compression using a motion estimation algorithm implemented in specific hardware like an FPGA in a surveillance camera.
Yes, or adaptive noise cancellation for hearing aids using filtering algorithms in a DSP, or dynamic packet routing in 5G networks using shortest pass algorithms that adapt to network congestion. All apply algorithms to achieve a specific, demonstrable technical purpose within a system.
Okay, finally, we come to the fourth exclusion. Computer program per se. This sounds like the most direct exclusion for software.
It does, but the per se is doing a lot of work here.
Yeah.
What's explicitly excluded? Claims that are only about computer programs themselves. The code, sets of instructions, routines, subroutines. Also excluded are claims directed solely to computer program products. Storage mediums with instructions, like a CD-ROM or USB stick claimed only by the program stored on it. Databases defined only by their structure, or computer memory claimed only by the instructions it holds.
So you can't patent source code itself or just a disk with a program on it.
Correct. It's the in-isolation aspect that's key.
Ah.
But what's not excluded, this is where that ancillary thereto or developed thereon legislative intent comes back in. The exclusion is not absolute.
Okay.
There's scope for patentability if the invention, even if implemented in software, provides a technical solution to a technical problem through technical means, achieving certain technical effects that are beyond mere incidental effects of using computer.
And crucially, as we discussed with the Raytheon case.
Exactly. Crucially, this does not necessitate novel hardware. The Delhi High Court has been very clear on this point repeatedly. The software itself can confer the novelty and inventive step if it produces that technical effect.
So how is this assessed?
First, you construe the substance of the claimed invention as a whole, identifying its essential technical features, EPFs. What's the core technical contribution? Then, identify the core problem being solved and the proposed solution. Is it a genuine technical problem? Is the solution inherently technical? And finally, you determine if that technicality results in a technical effect that goes beyond a mere incidental effect, like the inherent speed increase you get from simply using a computer instead of doing it manually. It needs to improve the machine's functionality or achieve something technically new.
Let's talk about examples of these patentable technical effects, maybe drawing from Table 1 and the guidelines. What kind of things qualify?
Well, anything that genuinely boosts the internal system efficiency or functionality of the computer itself. Think faster data processing achieved through a clever software method, like enabling hardware to process output faster than it normally would. More efficient data storage, like an improved caching algorithm. Optimized memory utilization, or maybe efficient data searching and indexing techniques that demonstrably improve overall system performance.
So improvements inside the box.
Yes. Or better data compression algorithms, enhanced security implementations like a novel cryptographic method or an intrusion detection system that technically analyzes network traffic patterns in a new way. Efficient resource management, balancing CPU load, network bandwidth allocation, or improved error detection and correction methods in data storage or transmission. All technical improvements to how the computer operates.
What about controlling things outside the computer?
That's another major category. If the software governs external devices or physical processes, this includes precise control over machinery, like industrial robots, 3D printers, improved signal reception or transmission, like advanced noise filtering or modulation-demodulation techniques implemented in software-defined radio, real-time monitoring and control of physical equipment, like sensors in an IoT network or medical monitoring devices.
Embedded systems, too.
Definitely. Embedded code that dictates specific hardware actions in a novel way. For instance, optimizing power consumption in an IoT device based on real-time conditions. Or software generating control signals for autonomous vehicles based on processing sensor data in an inventive way. Basically, software making physical hardware do something better, more precisely, or in a new, technically inventive way.
And then there are other concrete technical implementations mentioned.
Yes, things like medical image analysis using inventive algorithms that lead to technically better diagnostic outcomes, not just displaying an image. Optimizing data synchronization and consistency in complex distributed systems. Accurately simulating complex technical or physical systems, like weather patterns or protein folding, using novel computational models. Developing more efficient training methods for machine learning models, or using efficient signal processing techniques to solve a specific technical problem within a device. These all demonstrate a clear technical contribution beyond just running code.
Okay, now for the flip side. What are examples of things that lack that technical effect and would likely fall under the computer program per se exclusion? Table 2 in the guidelines gives some pointers.
Right. The core exclusions are, as we said, computer instructions or code claimed in isolation, or software merely defined by the storage medium it's on a program on a disk, without describing what technically inventive thing that program does.
What about data organization?
Methods for just organizing data are generally excluded if they're detached from a technical process or system that produces a tangible technical result. For instance, a new file format claimed just for its structure, without demonstrating improved storage efficiency or faster access. Or a hierarchical data structure designed simply for making organizational charts.
And simple automation.
Simple automation of tasks that were previously done manually is often excluded if there's no additional technical gain beyond the inherent speed of using a computer. Automating bookkeeping, basic accounting, or employee scheduling using standard methods usually falls here.
What about presenting information?
If the main function is just displaying data visually or textually, without a technical solution embedded in the data handling or display method itself, it's likely excluded. Think of a new layout for weather information on a screen, or generating standard business charts using readily available tools. The novelty is aesthetic or informational, not technical.
Rules for games, mental exercises.
Generally excluded. Programs implementing rules for new chess variants or software designed solely to solve Sudoku puzzles are not considered technical inventions.
Mimicking human reasoning.
Basic expert systems or software that diagnoses diseases simply by matching symptoms from a database, without any technical innovation in the process, like a novel algorithm or improved system integration, are typically excluded. The focus is on whether there's a technical advance, not just replicating a known intellectual process.
Aesthetics. Artistic creation.
Programs primarily for generating digital art or music based on predefined rules or user input usually lack a technical effect and are excluded.
And simple information retrieval.
Simple information retrieval or database lookups, like a system generating a customized playlist based solely on stated user preferences, lacking a technical effect on the system's operation or music processing. Or search engines using standard keyword matching techniques often lack the necessary technical effect on the underlying system itself.
Okay, let's make this concrete with a non-patentable computer program per se, example from the source material, a system for recipe management. The claim might describe modules for inputting recipes, storing them, searching, displaying them, scaling ingredients mathematically, and generating shopping lists.
Yeah, the analysis here is that the core purpose is organizing and managing culinary recipes purely for user convenience. The problem being solved is non-technical. It's personal information management. The solution uses standard programming techniques, databases, UI elements, on a general-purpose computer. There's no discernible technicality beyond the incidental effect of making user choices easier or faster than using a physical cookbook.
And this aligns with many other non-patentable examples in the annexure, like methods for scheduling employee shifts, systems for generating standard business reports, methods for creating digital art, systems for managing personal finances, generating playlists based only on user preference, automated invoice generation, scheduling social media content, generating Sudoku puzzles, loyalty point management, and template-based email generation.
Exactly. All these involve automating administrative, creative, or informational tasks without demonstrating a novel technical effect on the underlying computing system, or achieving a technical solution to a technical problem. They just use the computer as a tool for non-technical tasks.
In stark contrast, let's look at an adaptive network optimizer, which could be patentable. This is described as a system that actively monitors network conditions, analyzes the data using an adaptive optimization module, the software brain, and then transmits control commands to the network interface controllers, the hardware to dynamically adjust transmission parameters like power levels, frequency bands, or routing paths.
Right. The goal here is to actively maintain throughput and reduce latency in changing network conditions.
So the problem is technical.
Absolutely. Maintaining high-performance data transmission in dynamic and often congested network environments is a core technical challenge in communications engineering.
And the solution?
The solution is also inherently technical. It involves real-time analysis and manipulation of fundamental network transmission parameters, power, frequency, routing, and directly leverages specific hardware capabilities, the NICs, to implement these changes. It's not just processing data, it's controlling the network's physical layer behavior.
And the technical effect?
It's demonstrable and significant.
Right.
Higher data throughput, reduced latency, enhanced network robustness against interference or congestion, and more efficient use of network resources. This is a clear technical solution to a technical problem that improves how the communication system fundamentally works. It goes way beyond just running a program.
And this aligns with many other patentable examples given, like adaptive traffic signal control using AI and sensors, data compression methods for cloud storage using context-aware algorithms, adaptive error correction in wireless communication, efficient memory management in embedded systems, secure IoT device communication using lightweight encryption, automated drone-based crop monitoring using image analysis, real-time financial fraud detection using ML, efficient spectrum allocation in wireless networks, real-time network intrusion detection using deep learning, and secure access systems for industrial automation using hierarchical tokens.
Yes, in all those examples, the software is performing a technical function that results in a tangible technical improvement or solves a specific technical problem, often interacting with hardware or the physical world in an inventive way.
Okay, now let's navigate the really cutting edge. Artificial intelligence, machine learning, deep learning, blockchain, and quantum computing. These technologies, they utilize incredibly complex computational architectures and algorithms for tasks like pattern classification, predictive analytics, and in the case of quantum, potentially much faster computation. It's truly revolutionary stuff.
It absolutely is. But while incredibly powerful, it's important for patentability purposes to remember that these technologies are fundamentally built upon mathematical models, learning algorithms, and abstract principles.
Like?
Well, blockchain relies heavily on cryptographic principles and distributed consensus ideas. Quantum computing leverages the concepts of quantum mechanics, like superposition and entanglement. AI and ML are based on statistical models and learning algorithms. The core ideas themselves are often abstract or mathematical.
And this presents a challenge for patents, doesn't it? There's this thing you called the future vision problem.
Exactly. A key challenge, especially with these rapidly developing fields, is that sometimes prospective use case scenarios and future possibilities are extrapolated and described in patent applications almost as if they are already achieved solutions, but without the necessary specific enabling details.
Like saying, my AI will solve world hunger, without explaining how.
Sort of, yes. Especially given the theoretical and algorithmic nature of many of these inventions, it's easy to describe a grand vision. But the patent system requires more.
So the core question for patentability remains the same, even for these advanced technologies.
Yes. Does the claimed invention transform these abstract principles or algorithms into a real-world, tangible application that demonstrates a concrete technical effect or improvement? That's the bar they have to clear, just like any other CRI. You can't patent the abstract concept of AI or blockchain itself.
Okay, let's do a deeper dive specifically into AI, machine learning, and deep learning related inventions. Starting with a fundamental question, inventorship. Can AI be an inventor?
That's a hot topic globally. But under current Indian patent law, the answer is clear. AI-generated inventions, meaning creations potentially made by AI systems autonomously or with very limited human intervention, are not patentable, as AI cannot be termed a person or the true and first inventor. Only humans can be inventors.
But what if AI is used as a tool?
Ah, that's different. AI-assisted inventions made by humans using AI as a sophisticated tool in the inventive process, can certainly be patentable. The key is that a human inventor must be identifiable. And of course, the invention itself must meet all the standard patentability criteria, including demonstrating that crucial technical effect through its tangible application. The AI is a powerful assistant helping the human inventor, but it's not the inventor itself in the eyes of the law.
Got it. Now, sufficiency of disclosure, you called it the quid pro quo earlier. This seems absolutely paramount for AIM-LDL.
It really is.
Yeah.
Because of the sometimes speculative nature of AIM-LDL applications and the complexity of the models, the disclosure in the patent application must be fully and particularly enabling with regard to the claimed invention. You can't just wave your hands and say, AI model achieves X. You have to explain how.
Is there case law on this specifically?
Yes, a critical recent case is Caleb Suresh Motopally versus Controller of Patents from January 2025. The Madras High Court looked closely at sufficiency of disclosure for an AI-related invention. The court observed that disclosures must sufficiently enable a person skilled in the art to practice the invention. And interestingly, the court effectively took on the role of a notional PSIDA, hypothesizing a software engineer with expertise in AI and allied fields, and asked, could this person actually make this invention work based only on what's written in the patent application?
And what standard did they apply?
The undue experimentation standard. The court found that the claimed invention in that case, which was about creating a super-augmented persona through AI, merely coalesced the disclosures and discussions in the patent and non-patent literature, basically. It just summarized existing knowledge without providing any specific directions for the adoption of these technologies for persona extension and augmentation.
So it described the ingredients, but not the recipe.
A good way to put it. The court emphasized that to meet the enablement requirement, undue levels of experimentation entailing the deployment of inventive faculty should not be required to work the invention. The specification must lay bare the purported working and usage. You can't just describe a problem and allege you solved it with AI without showing how it's actually done step by step with enough detail for replication.
So the disclosure must ensure reproducibility without making the skilled person invent it all over again.
Precisely. Let's walk through some illustrative scenarios from the guidelines showing how you might satisfy sufficiency of disclosure for different types of AIM-LDL inventions.
Okay, scenario 1. The invention is about transforming a complex input to an output via complex AI logic, like an AI model.
Right. Here, you must clarify this transformation by detailing known processes and variables sufficiently for reproducibility. Crucially, you should include test results or other evidence validating the model's accuracy and reliability. For example, imagine a system for translating handwritten medical prescriptions into structured electronic medical records using deep learning. Disclosure must include specifics like the neural network architecture details, number of layers, depth, activation functions used, the characteristics of the dataset used for training, example 1 million labeled prescriptions covering diverse handwriting, the pre-processing steps applied to the images, and validation results showing perhaps significantly higher field-level extraction accuracy compared to existing methods or manual transcription. The technical effect here is tangible, reducing human transcription errors and improving processing speed in healthcare workflows.
Okay, scenario 2. What if your invention uses an already trained AI model, maybe one that's publicly available?
Even then, you need sufficient detail. You must clearly define the input-output correlation the model achieves, identify the nature and suitability of the data used for its original training. Was it appropriate for your claimed application? Describe the learning model itself, its architecture, algorithm type. Outline the training methodology used, if relevant, hyperparameters, optimization techniques, and again, show predictable and reliable results with validation metrics for your specific application. An example could be a system for predicting failures in industrial machines using recurrent neural networks, RNNs, trained on historical sensor data. Disclosure needs specifics about the training dataset, Yarrachi wind turbine SCADA data, sensor types included, sampling frequency, how the input sensor readings correlate to predicted failures, the specific LSTM network architecture employed, the training methodology, optimizer used like Atom, learning rate, loss function, and evidence of high prediction accuracy in real-world or simulated tests. The technical effect is clear, reducing unplanned machine outages and optimizing maintenance schedules, a direct industrial benefit.
Scenario 3. What if the key inventive part is actually the data preprocessing before it even gets to the AI model?
That's common. If preprocessing is crucial for the invention's success, then all significant steps and functions in that preprocessing pipeline must be disclosed. And importantly, their correlation to the end model's performance must be made clear. A PSIDA must understand the link between the raw input data and the process data that feeds the model. Think of classifying crop types using satellite imagery and deep learning, where extensive pre-processing is needed to correct for atmospheric distortion, calculate vegetation indices, and segment fields. Disclosure needs the step-by-step pre-processing pipeline, naming specific tools like send-to-core if used, detailing steps like NDVI calculation segmentation methods, explaining how each step improves performance, describing the subsequent CNN model structure, the training dataset characteristics, and providing comparative performance benchmarks showing the material effect of your pre-processing. The technical effect, enabling large-scale, high-accuracy crop classification, enhancing land use management and food security monitoring.
Scenario 4. What about reinforcement learning, where the AI learns by interacting with an environment?
For RL inventions, you absolutely must specify how the system interacts with its environment. This means detailing the agent's interactions, the definition of states, the available actions, and crucially, the reward function design. Omitting these details can lead to a non-enabled disclosure because the learning process itself depends critically on these elements. For instance, an adaptive urban traffic optimizer, AUTO, using deep reinforcement learning, DRL, for real-time graphics signal control. Disclosure requires specifying the DRL architecture, e.g. Deep Q Network DQN, how the traffic state is represented mathematically, the agent's action space, which signal timings can change, how the reward vanish function is precisely calculated to encourage better flow, how the agent interacts with the environment via IoT sensors and signal controllers, and the training methodology, simulation environment setup, use of transfer learning perhaps. The technical effect is tangible, optimizing urban traffic flow, reducing congestion, fuel consumption, and CO2 emissions.
Scenario 5. What if the invention claims to improve the computer's internal structure or operations using AI?
In that case, you need to describe how the underlying algorithm interacts specifically with the hardware or system architecture. Specify how it optimizes internal performance metrics like data storage efficiency, task scheduling, processing speeds, or memory usage. An example could be an OS kernel optimization for task scheduling using neural networks. Disclosure needs a precise definition of the input features fed to the network. DAG, task priority, cache usage, the rationale for selecting those features, the neural network architecture, details on how it integrates with the existing OS scheduler like Linux's CFS, the sources of training data, system logs, benchmarks, and performance results demonstrating reduced latency or increased throughput compared to the standard scheduler. The technical effect is enhanced CPU resource utilization and overall system performance.
Scenario 6. This is interesting. What if the inventiveness comes primarily from the unique characteristics of the training dataset itself?
That can happen. If your invention's novelty and non-obviousness depend critically on unique traits of the training dataset you curated or used, these traits must be disclosed, unless a PSIDA could readily identify or reproduce them without undue experimentation. We usually don't need to disclose the entire voluminous dataset itself, but you must define its key characteristics sufficiently. Consider an invention improving facial recognition accuracy specifically for elderly individuals, trained on a unique, difficult-to-obtain dataset. Disclosure needs to specify the crucial dataset attributes, e.g. large number of individuals aged 65-90, diversity in lighting conditions, poses, occlusions relevant to elderly, details of any modified facial recognition model architecture used, example, a modified FaceNet, and quantitative comparison results against baseline models trained on standard datasets, clearly showing the material improvement achieved due to your specific dataset. The technical effect. Reliable person identification in contexts like elderly care facilities, reducing false negatives and improving safety.
Okay, 2 more AI scenarios. Scenario 7. What if the invention is a completely new learning algorithm?
Then you need to provide a comprehensive description of the algorithm itself. This includes its unique elements, its mathematical foundations, the operational steps involved, the full architectural layout if it's a network, the detailed training protocol, and benchmarking results comparing it against existing state-of-the-art algorithms to prove its novelty and advantage. For example, a truly novel deep learning algorithm designed for crop classification, perhaps with a custom neural network architecture you invented. Disclosure requires the full architectural layout, layer-by-layer details, input-output specifications, parameters, activation functions, the precise training protocol, loss function used, optimizer settings, batch size, and benchmarking comparisons on standard datasets demonstrating its superiority.
And the alternative, Scenario 7b. What if the inventiveness lies not in the algorithm, but in the data engineering, how data is created, curated, or used to get a breakthrough result with a standard algorithm?
In this case, the focus of the disclosure shifts. While the algorithm used might be standard and described generically, you must focus on detailing the innovative data-centric processes. This means describing the data pipeline, the sequence of handling operations, the specific environment or tools used, the technical rationale behind your innovative data steps, and a validation methodology demonstrating the improvement achieved due to your data approach. An example here could be an automated system for generating a high-fidelity, uniquely harmonized multi-seasonal satellite imagery dataset, which then allows a standard classifier to achieve unprecedented accuracy. Disclosure needs the specific data pipeline steps, the sequence of operations, like cloud masking, temporal harmonization, the environment used, the technical justification for the novel steps, and validation showing the improved quality or utility of the generated dataset. The core invention is the data engineering, not the known algorithm applied to it.
That's a very helpful breakdown for AML disclosure. Now, moving beyond AI, let's briefly explore quantum computing-related inventions. We mentioned the core principles: superposition, entanglement.
Right, and quantum tunneling. Implementations involve extremely specialized components. Qubit technologies, like superconducting transbonds or trapped ions, quantum gates, specialized chips and processors, massive dilution refrigerators to keep things near absolute zero, cryoperm shields, sensitive qubit signal amplifiers, compilers that translate algorithms into quantum operations, and complex quantum error-correcting codes. It's incredibly complex engineering.
So patentability follows the same logic. Abstract ideas out, practical applications in.
Exactly. An abstract idea or a theoretical concept, like the principles of quantum mechanics themselves, is not patentable. However, a real-world, tangible application that transforms these principles into a concrete technical effect or improvement, think optimizing a specific logistics problem using a particular quantum algorithm implemented on specific hardware, or inventing new hardware for better qubit control or coherence, may be patentable. Again, demonstration of a concrete technical effect is crucial.
Can you give an example?
Sure. Example 17 in the guidelines describes a hybrid quantum classical computing system for dynamic optimization on a superconducting qubit-based quantum processor. This invention involves a quantum processing unit, QPU, with specific transbond qubits made of niobium titanium alloy on a sapphire substrate, working closely with a classical control unit, CCU, running an ML algorithm for real-time feedback and error mitigation. It also includes a specialized compiler and the necessary cooling shielding system.
And the disclosure.
Disclosure would need details on the materials, dimensions, and design of the qubits, the CCU architecture, the compiler flow diagram, specifications of the cryogenic environment, and block diagram showing how it all connects. The technical effect claimed is enhanced fidelity and minimized incoherence during computation, directly increasing the performance and reliability of the quantum computing system for specific tasks. That's a tangible technical improvement.
Another quick quantum example.
Example 18, a chip-based photonic quantum computing device using reconfigurable optical circuits. This involves a silicon photonic chip with embedded waveguides, beam splitters, phase shifters made using CMOS compatible processes, integrated single photon sources, thermal optic tuning elements, and superconducting nanowire single photon detectors, SNSPDs. Disclosure needs chip layout details, the control logic for implementing quantum gates using these components, test data, like insertion loss, extinction ratios, and perhaps a sample execution of a quantum technique. The technical effect is enabling high-speed, low-noise quantum operations with enhanced gate fidelity and scalability, specifically leveraging the potential immunity to thermal decoherence offered by photonic systems.
Fascinating stuff. Okay, finally, let's touch on blockchain-related inventions, core concepts, peer-to-peer, distributed ledger, immutability, consensus.
Right. It enables secure, transparent, consensus-based transactions using technologies like non-repudiation, digital signatures, encryption, and often smart contracts.
And patentability, same story.
Same story. Similar to AI and quantum, the theoretical concept of blockchain itself, or just the idea of a distributed ledger, is not patentable. However, a real-world, tangible application that uses blockchain technology to demonstrate a concrete technical effect or improvement is potentially patentable.
What about disclosure requirements here?
Applications must clearly define the key components: the nature of the distributed ledgers used, the functionality of any smart contracts involved. Often high-level functionality is enough, unless the implementation of the smart contract itself provides the technical effect, the specific consensus mechanisms employed, proof of work, proof of stake, etc., the cryptographic processes used, and the network configurations, like block structures, how blocks are linked.
Can you give an example of a potentially patentable blockchain invention?
Example 19 in the guidelines. A computer-implemented method for executing a rental agreement over a blockchain network. This involves deploying a smart contract containing the rental terms onto a blockchain. having a decentralized node receive rental requests, verifying cryptocurrency payment, automatically generating a digital access token upon payment confirmation, triggering the activation of a physical lock or virtual asset access, and immutably recording all these events on the blockchain.
And the disclosure needs.
Details on the smart contract logic, especially the auto-triggering parameters, the protocol stack used for communication between the blockchain and any IoT hardware, like the smart lock, specifics of the events recorded on the chain, and maybe fallback mechanisms. For example, using an external oracle for data, handling failed payments.
And the technical effect.
The technical effect is the automated enforcement of access and payment rights without needing a centralized server, thereby reducing potential for fraud and decreasing transaction latency. It also involves the technical integration of physical IoT devices controlled securely via the blockchain for automated access. That interaction provides a tangible technical outcome.
One more blockchain example.
Example 20. A decentralized system for supply chain provenance tracking. This might involve a private blockchain using a hybrid consensus mechanism, like proof of authority combined with practical Byzantine fault tolerance for specific nodes, smart contracts defining rules for product provenance verification and routing updates, and perhaps an off-chain data anchoring mechanism using Merkle trees stored on-chain to verify larger data stored off-chain. Disclosure would need details on the specific blockchain platform setup, the detailed functionality programmed into the smart contracts, how off-chain storage, like IPFS, is integrated with on-chain anchoring, the specifics of the hybrid consensus mechanism, and any protocols for integrating data from external sources like trusted oracles or IoT sensors tracking goods. The technical effect is improved supply chain transparency, reduced potential for counterfeit goods or fraud, and potentially real-time optimization of logistics based on trusted shared data. Again, a concrete technical improvement enabled by the specific blockchain implementation. Hashtag outro.
So, wow. We've really journeyed through the quite intricate landscape of computer-related inventions today. We've tried to understand how Section 3K of the Indian Patents Act 1970 guides what can and cannot be patented in India in this rapidly evolving space.
Yeah, from the broad strokes of mathematical methods and business methods to the really specific nuances around algorithms and computer programs per se, the recurring theme seems crystal clear, doesn't it?
It really does. Patentability hinges on demonstrating a technical solution to a technical problem, resulting in a tangible technical effect that goes beyond just mere automation or abstract ideas or calculations.
Exactly. Hopefully you now have a better sense of the critical tests involved, the absolute paramount importance of detailed and enabling disclosure, especially for these cutting-edge fields like AI, quantum computing, and blockchain, and how they're being evaluated always through that lens of technical contribution.
So the big picture here, the main takeaway, is this. It's truly about the substance of the invention and the technical contribution it makes. Does it fundamentally improve how a system operates? Does it interact with the physical world in a new, inventive, technical way? It's not just about having a clever piece of code or a new way of doing business online.
And remember that landmark point. Your software doesn't necessarily need to come packaged with brand new hardware, but it absolutely needs to make the hardware, even general-purpose hardware, do something novel and technically impactful that it couldn't do before or do nearly as well.
Right. So here's a final thought for you, our listener, to mull over. As you look around at the world and you see all these emerging technologies, what surprising new application, maybe one that seems purely computational or software-based today, might achieve patentability tomorrow by fundamentally transforming a physical process or a core system operation in a way we haven't thought of yet?
Yeah, what technical problem are you seeing out there that could be solved not just with an abstract idea or algorithm, but with a truly inventive implementation that delivers that crucial technical effect? Something to think about.